Flying cars have been part of science fiction fantasy for nearly a century, but now fantasy is turning into reality, and the auto industry is starting to explore how it can play a role in what could be a brand new market. Flying cars could be less than a decade away. Coming up next on Autoline This Week. Underwriting for the production of Autoline This Week has been provided by RSM.
Prepare for challenges specific to your business by working with trusted advisors who help turn obstacles into opportunities. Experience the power of being understood. RSM, Audit, Tax, and Consulting for the Middle Market.
And now, here's your host, Jon McElroy.
I want to thank you all for joining us on Autoline This Week. You know, with this move to autonomous cars, mobility services, I have a lot of people ask me, when are we going to have flying cars? When is it going to be like the Jetsons? And I tell them, just wait, it's just around the corner. And they all laugh because they think I'm joking. I'm not joking. It is coming. And we're going to be talking about that on today's show because my special guests include Bill Foy. He's the Senior Vice President of North American Engineering for the supplier Denso. Bill, great having you on the show. I can't wait to hear you talking about this.
Yeah, it's great to be here, John.
And Jon Rimanelli, he's the founder and CEO of a company called ASX, which stands for?
Aerospace Experience Technologies.
All right, John, great to have you back. We had you here a couple of years ago, but progress is moving forward. How do you assess it? You know, when you were here a couple of years ago, nobody was talking about flying cars, or let's call them passenger drones, or Vtols, vertical takeoff or landing craft.
Yeah. So the people in the business like to refer to them as electric Vtol aircraft or electric vertical takeoff and landing aircraft. And it is certainly taken off, pun intended, over the last couple of years. I mean, certainly it has helped when you've got major transportation players such as Uber out there sort of, you know, marketing and planning this future for on-demand point-to-point air mobility. And so it's been really exciting, and it helps us validate our business case because we're no longer just one of a few crackpots in the business that are actually working on it.
Bill, I'm intrigued that an automotive supplier is looking at playing in this space. What are you doing and why?
Yeah. Well, let me answer the why first. So Denso is a company that looks to contribute to society as a whole. And about 3 years ago, we expanded our vision into a greater mobility space. So not just 2D, but now going 3D. And we did it for a few reasons. We look on the ground for safety, and if you have less cars on the ground, it's going to be more safe. But then when we started to look at urban air mobility, there were so many synergies. There were so many synergies between the automotive industry and this new space. And we felt that this is a great opportunity for us to begin to move into it. So as we started to look, we recognize it's probably something we can't do on our own. So we partnered with Honeywell, and we're currently doing a complete investigation to electrify it. So the E that John talked about, we're moving into that space first right now, and it's exciting.
John, this plays right into when you were on the show a couple of years ago, you were the one preaching that there's a lot of automotive technology that would be perfect for this. So you must love what Bill is saying.
Yeah, I was actually very excited when I read the news. I know the folks at Honeywell very well, and they've got great technology there. I was always sort of looking forward to more sort of mature industry joint ventures, such as the one that they've put together that can sort of merge the two disciplines. When you really sort of deep dive the requirements of an electric Vtol aircraft and the requirements for an electric vehicle, what you find is that there is an existing ecosystem that has and a supply chain that has a lot of capability that really matches the requirements that we really need on the eVTOL side for air mobility. So when you think about the environmental requirements, and those are really parallel what's already happening on the ground.
Bill, what opportunities do you see for Denso in this?
Yeah, so first we're looking at the electrified area. But when you look at the whole cabin experience, so how you heat it, how you cool it, what people do in it, there's everything that we do in cabin in a vehicle is going to be available in this urban air mobility space as well. So it's a great synergy for us that it allows us to be able to move into this area. But it's also what we're going to learn, because as we start thinking about autonomous drive vehicles and going 500,000, 1 million miles, that's what we have to be able to take from the aerospace industry. So how do we do maintenance and repair? What does that look like? What's that new business model going to be? So it's really back and forth for us, so many learning opportunities.
When the both of you talk about electric VTOLs, you're not talking about battery powered, are you?
Well, I would say that batteries are certainly one approach. You certainly could run them like a sort of like a freight train, and you could have sort of a turbo generator that generates energy that powers up your electric motors. That's one approach. It's not the emission-free approach, but yes, electric lithium polymer batteries. Having hybrid configurations of that, but yeah.
I think one of the things you need is quiet, right? So you're flying over cities, typically in these types of environments. So you need quiet, you need reliable, you need safe, and quiet is where the electric comes in. So when we look longer term, we think electric is a big part of it.
Longer term, I know, but a lot of the examples I see of these vehicles right now is hybrid electric. They're not trying to just do it with batteries alone. They've got some onboard power source that provides electricity to keep this thing aloft and give it greater range. Is that what we're going to see short term, and then maybe go to a full battery electric at some point?
You start?
Yeah, I think so. I think that, just like automotive, what we're seeing, right, from ICE to hybrid to full electric at some point, we see it being the same. And of course, there's this cost curve of technology. So as we talk about in the automotive industry and looking at what is that, 2025 or 2027, when we can break that cost opportunity to make it affordable, it's going to be the same, I believe.
So one of the biggest challenges with electrification of aircraft is, energy density. Currently, I would say that we're looking at about 200 to 250 watt hours per kilogram in energy density, and really needs to be at least 300. I've seen a few companies out there modeling 700 watt hours per kilograms. They don't know where they're going to get those batteries from, but they don't exist. So having range extension capability, whether it be an internal combustion engine that turns a generator, or it's a fuel cell, or it's a direct turbine generator / type model. You got to come up with a way to justify the investment and the expense that goes into building and certifying an aircraft. And the energy density currently available today it's not really doing it for me. Right? We really need to have a hybrid approach. We do have a hybrid, a purely electric version that we're going to be flying and testing. I'm just not so sure that's going to be the first vehicle that we come out with.
What's interesting to me is to see Daimler, the parent company of Mercedes-Benz, bought a passenger drone company called Volocopter. Audi and Aston Martin have shown design studies going along that way. And of course, the aerospace companies, Airbus, Boeing, Bell are all in it. How do you guys think this is going to shake out? Are we going to see more joint ventures, more cooperation between the aerospace industry and automotive, or how do you think that'll roll out, Bill?
I think you have a huge interest from both sides. And so from the automotive industry, you see a lot of players like that, and there's more than that are interested in this area. Because I think they've all expanded their vision into mobility as a whole. So whether it's going to be in the air, on the ground, on the sea, various types of ground transportation, they're interested in every aspect of this. And when we look at urban air mobility, I think the interest is really about speed, right? I mean, when you can do something in 8 minutes that might take you an hour and a half in traffic, that becomes very interesting, and it becomes a competitive space for ground. So I think any of the companies that are really interested in true mobility are going to follow this idea and this industry.
Yeah, agree with that. So, so having been, working and developing this aircraft solution over the last few years, what I found is that you've got traditional aircraft companies who say, man, this is certainly the future, but we don't have sort of the capacity to run at the rates that the industry sort of projecting demand will yield. Mm-hmm. And you have the automotive OEMs that certainly, I believe, I've heard that the top one or two objectives is to invest in and develop an urban air mobility solution. The problem is that, do they want to risk their current business models by developing those in-house, or do they invest in an outside organization and contribute, intellectual property, know-how, maybe even industrial capacity and expertise? So one of the things that I'm working on right now is actually creating a vehicle for traditional automotive and traditional aerospace companies to contribute intellectual property and know-how, capital towards building an all-new factory that can produce these aircraft systems very much like we produce cars today. Very lean, very flexible, because there's just a huge interest in making this promise a reality, that there really needs to be a facility that's really designed and like vertically integrated, as far as I'm concerned, to produce these things at scale. So that is something that we're actively working with some very, very large aerospace companies on that at the moment. And once we close those deals, we're going to be reaching out to our friends in automotive and saying, hey, we've de-risked this opportunity. Here's a way for you to get in and participate without putting the rest of the organization and your business at risk. And I feel like that's really, it's resonating with both the aero and the automotive players. So that's what we see happening, a convergence.
I think it's really interesting because when we started working with Honeywell, we thought it was all about our technology and the reliability of our technology. The third element was just that, it's our mass production capability. Yeah. Is they want to work with partners who are making 1 million units a year. Yeah. And not that urban air mobility is going to get to 1 million units a year quickly, but they can see the future and they need to have this mass production capability themselves.
So what is the future then, Bill? I mean, how big could this become, and when are we going to start seeing these things fly around?
I'd love to know that too, John. We think it's going to be significant. And of course, there's some hurdles to get over. There's some technology hurdles that John talked about a little bit to get to pure electrification. And there's regulation hurdles overall. And then there's finally consumer acceptance hurdles to get there. But I think once you can get over those three areas, and maybe there's a few more, but at least those three, we think that it is a huge industry, and not just in North America, but globally.
Yeah, yeah, well, the problem of congestion is a global problem. And as you look at, I think the UN indicated that 2/3 of the world's populations are going to be living in urban centers. And there's one thing that's certain, is that they're not making any more real estate, right? Mm. So there really isn't any more room for cars. So we really need to look at ways to elevate traffic.
Like Bill was saying, go 3D, not
right.
just 2D.
So we're going to start to see demonstrations that are already happening today. I mean, in Dubai, they're Volocopter's engaged. They've got a unique approach. Like automotive, there's the mobility concept. There's 4 corners of it, and there's cars and trucks that meet each corner of that. So you'll see a number of vehicles that are going to be produced and demonstrated. But I would say, 2024, 2025 is when we start to see sort of more commercial opportunities to participate. Up until then, we've got to do a lot of validation. It's really critical that we put a system together that is failure tolerant. On the ground, we can tolerate a failure because we can, for the most part, pull over. In the air, we need to have a system that can tolerate a failure and go, okay, well, we do have a problem on engine number 4, but we're going to keep going because it can tolerate that. So I think 2024, 25 is when we'll really start to see it kick off, and we're just really looking forward to exercising our technology. And
John, that's right around the corner.
Yeah.
That's not way down the road. 2024, 2025, that's the blink of an eye.
It's not far away, and we hope that we can continue to make progress. I think the main thing that we have to do is really de-risk it for the mass traveling public. They're really worried. I mean, in the context of some of these issues with the 737, which a lot of folks have been like, man, this is really going to impact. I'm like, I think in a good way, because what we're not going to do is we're not going to get complacent. We're going to be very, very focused on, redundancy, reliability, and making sure that we can get the job done. That's really the most important thing, is making sure we get it right. Because if we don't, it's just, it'll set the entire industry back. And we need solutions. It's not just some, this is a solution that is desperately needed for urban centers. Yeah, we need it.
Mm-hmm. Yeah, Bill, I'm sure you see it the same way. And Denso, of course, has a great reputation for quality and reliability.
Mm-hmm.
Yeah.
Yeah, we do see it the same way. I'm interested when you say commercial. Are you thinking moving of things or moving of people?
I'm thinking moving of things, cargo.
Yeah.
I think a few entities will be moving people. It depends. The regulatory framework that exists today will allow for certain configurations to actually do the job of moving people without new standards. One of the latest, two examples of standards that need to be established are going to be, reserve requirements on batteries, and then the standards for, validation and certification of electric motor, which at the end of the day is just a performance-driven validation process, right? When does it break? How often do you have to replace the bearing? Okay, well, if it breaks after 16,000 hours, we'll certify you for 8, but we'll start with 4. It really is just sort of establishing what the rules are, and I think automotive can do a really great job of demonstrating how we validate high volume produced components and systems, because we have to build the first one and the millionth one the very same way, and they have to perform the very same way. And that's something I think the automotive industry has done very well, and the aerospace industry is very excited to learn about. How we do that. That's not easy to do.
Where does the U.S. stand in all this? I mean, I'm more familiar with what's going on here, but how do we stack up against the rest of the world in this technology?
Let me answer it from, I went to the Uber Elevate conference, and what I really loved was to see the government involvement and the desire from the U.S. government to want to help to lead the U.S. to become the world leader in this area. So they talked a lot about the regulations and how similar it is to drones, and a lot of the regulations can already exist and they can use those. But it was so interesting for me to see that our U.S. government wants to collaborate with industry to bring this to market quickly. So for me, that's really exciting.
So I agree. The FAA has been really very, very friendly towards developers. They are looking to build partnerships with industry to enable this, because they do realize there's going to be a shift in productivity in the United States if we can connect the nation's 15,000 airports with the surrounding communities and really move people and product faster, 5 times faster, for maybe the same price as a rideshare. There are huge productivity gains. How we stack up in terms of other countries, well, certainly there's a lot of capability in Southeast Asia. Europe and the automotive makers in Europe are certainly, I think, ahead of us. Daimler's, as you mentioned, invested in Volo. You've got Audi, you've got BMW actively looking. I know Porsche is actively looking, but they already made investments. So I feel like the U.S. organizations are behind, and one of the things we look to do is optimize a solution that they can participate in.
We've seen an evolution, too, just in the last couple of years. The first passenger drones that I saw all kind of looked like helicopters with multiple rotors. Now it's more tilt wing with a pusher motor behind it. Bill, any ideas on how these things may actually end up looking?
You know, it's an interesting question. For us, in our working with Honeywell, we have the opportunity to go talk to all the makers to understand what they're doing and where they're going. Because for us, we want to be able to create a scalable design that can be used across for the majority of the designs. And Jon may know better what your competition's doing and what you're thinking, but we're seeing some differences that exist. But
So different that you are not able to make a common module, or can you?
We think so far about 90%.
Wow.
Yeah.
From an architecture standpoint?
Just from our size of our motor generator, the power density. Yeah.
Power density of motors and
Yeah.
Gotcha. So, yeah, there is certainly an opportunity to, develop and configure a modular propulsion system that could apply to a variety of configurations. There are 3 primary configurations today. One is a vertical takeoff and landing, strictly multi-copter type configuration. They're very, very inefficient aircraft. They sort of parallel a helicopter. They have a liftover drag of about 4 to 5. Okay, it means that they require a lot of energy to keep it aloft. So in order to improve that scenario, you have to add wings. You need a lifting surface. So now they have it's basically a 2-phase configuration where you'll see propellers that lift it up to an altitude with a set of wings and then a pusher prop that pushes it. And it's more efficient. You're looking at a liftover drag of like 8, 9, right? So it's a little bit better, but you got a stationary prop. They're very draggy. This is kind of like, I call these training wheels, right? And then there's the tilt wing, tilt rotor configuration. We have a tilt wing, which means it's a traditional looking fixed wing aircraft with a wing that tilts vertically. We take off vertically and then we transition into plane mode flight. So there's really the 3 different types, the most efficient being tilt wing, tilt rotor. Those are also the hardest to certify and build. So I think we're going to see a little bit of everything.
Is that what you're seeing, Bill? Is a little bit of all those?
We are.
Yeah.
I love the tilt wing though. It's so cool looking when you see that.
Yeah.
At least in videos. I haven't seen it live, but yeah.
It's an efficient machine.
Yeah.
It does the job. It very much resembles a traditional aircraft. It's what people are used to seeing, except the only thing that's different is the main wing tilts vertically.
Yeah.
So we decided not to try to pursue too many miracles. We looked back in time, we found, well, what have they done in the 60s? They've pretty much invented everything in the 50s and 60s. And tilt wings were demonstrated to be viable, except the powertrains were the Achilles heel. They transmissioned engines, and that proved to be the failure modes that killed those programs. We don't have those problems with electrification.
Of course, when I talk about these things, people always bring up the V-22 Osprey, which is in the U.S. military, which at least early in its program had a lot of issues, plane crashes and the like. I think
Single points of failure.
Yeah, but I think it's pretty reliable now, but you're saying you're doing something different than the V-22.
So that's a tilt rotor, right? So you've got 2 massive, propulsors that do the job of lifting the aircraft. Those are really optimized for hover operations. But if you were to have a hydraulic failure or a fuel flow failure in either one of those motors, you would end up with, a catastrophe. One of the great things about distributed electric propulsion is we can actually distribute the load and distribute the job of lifting across a number of electric motors and propulsors. So if you have 1 or 2 go out, it can still complete the mission, right? So that's one of the real revolutions here is this distributed electrification, which really makes it safer, more reliable than aviation has ever been before.
Bill, you mentioned that you went to the Uber Elevate conference. That must be intriguing that, here's Uber, a company that provides rides, clearly looking to the skies as the next step.
Yeah, and they have it all connected. So already they have all the data today to understand where people are going. So I think they have it figured out down to the point of where they're going to buy the property to put the pad already, because they understand where those ideal points are. And just imagine that you just can get an Uber vehicle to pick you up at your house, take you to a pod, and then take you to wherever else and have another vehicle pick you up, and it's all coordinated. So just thinking about that future, it creates that whole speed idea, and door to door is just a beautiful thing.
And you're saying that maybe for the same price as an Uber ride today?
I don't know about that. I think my personal opinion is that in the beginning it's going to be the premium type customers, and then as Uber gets the sharing part down and it's reliable and they get enough customers into it, then you're going to see the cost come down where it's more affordable for the middle class type aspect.
Mm-hmm. Jon, is that what you see too?
So I do. I think that it'll initially begin as more of a premium service, more of a a luxury vehicle price point. The ecosystem, the supply chain for vehicle suppliers is small, right? So the ones, you've seen the Bell Nexus. The rumor is it's $10 million before they add their margin. Very expensive machine. So I think that it'll start off as a luxury price point, and then as more vehicle providers get into the business and be able to bring down those costs, there's no reason why that we could see equivalent price points as an Uber X or an Uber Black Ride.
It's going to be fascinating to watch this develop. I know there's some pilot programs that are right around the corner. Mm-hmm. I know Uber in particular, I think they want to launch a pilot test in the next fall. So about a year from now. Mm-hmm. It's going to be amazing watching it. So I want to thank you both for coming in. Bill Foy with Denso, Senior Vice President of North American Engineering. Jon Rimanelli, the founder and the CEO of ASX. Fascinating discussion. Thanks to the both of you.
My pleasure.
Yeah, thank you.
Underwriting for the production of Autoline This Week has been provided by RSM.
Prepare for challenges specific to your business by working with trusted advisors who help turn obstacles into opportunities. Experience the power of being understood. RSM, Audit, Tax and Consulting for the Middle Market.